I'm now going to dial in Csaba, who is a former Objective by the Sea speaker. We are super stoked to have him dialing in from Europe to give what I think is going to be an incredible talk. So,
welcome everyone. I'm really sorry I couldn't make it to Hawaii, but please have fun on behalf of me and basically all the other European macOS security people, because I think none of us could make it. My name is Csaba Fitzl. For those who don't know me, I go by the Evil Bit on Twitter, and I will talk about the mountain of bugs today, which is basically either vulnerabilities inside the mount system operation, or how we can use the mount operation as an exploitation technique. Few words about myself. I'm working right now at Offensive Security as a content developer, and I'm the author of the new macOS control bypasses training, which is all about macOS exploitation pen testing. I used to be a red and blue teamer before at a large organization. I do macOS bug hunting as a hobby. I'm married, have 2 kids, and I really like hiking and trail running recently. And before we jump into the talk, I have another off-topic slide. Although I'm not in Hawaii, I'm also not at home. It happened that both Wojciech Regula, who is another macOS researcher from Poland, and me were invited to Croatia to give our talk about TCC. And actually, this is the first time we met in person. And although we already gave 2 talks together before, we never actually met in person. So it was fun, and we also met another macOS researcher here in Croatia. And if we talk about mountains, I took a really great trip today with 5,200 feet elevation. So I'm a bit tired, but it was fun. So let's jump into the agenda. First, I will talk about the mandatory access control framework. I think there is always a good cause to talk about this framework. Then I will talk about very briefly about the mount system call and how it ties, how the Mac framework is integrated into it. Then talk about the disk arbitration service. And then I will jump into a lot of vulnerabilities. First, I will cover a little bit of history. So first 2 CVs from 2017. The first was made by Patrick Puddle, and the other was presented in Pwn2Own or used in Pwn2Own. And then a few other vulnerabilities that I found. These are related to TCC bypasses, and also some privilege escalation on Fortinet, and finally some other tricks and new bugs in the pipeline, because this is not the whole list. So the mandatory access control framework. It has its origin in Trusted BSD. This is from where OS X took it. It's a framework implemented in the kernel, and it extends the kernel with the so-called policy modules. So what happens? The kernel has plenty of system calls, and there are lots of hooks in these system calls, which all call out to the Mac framework. And the Mac framework will basically iterate over all of the policy modules. So if those modules supports those hooks, that will be called. And these policy modules can permit or reject a specific system call or a specific action. This is really, really powerful. As of today, there are over 200 hooks in the kernel. And Apple uses it extensively, like all the sandbox, Apple mobile file integrity, endpoint security is all really based on the Mac framework. And the the policy modules can also call out to user mode daemons if they want. So like the MFD or the TCCD process are typical user mode processes which are being used by these kernel modules. So again, it's really powerful, and it was part of the KDK, the kernel development kit, till OS 10.12, but it was never officially supported by Apple. So they really didn't want people writing their own Mac policy modules. So they eventually removed the header from the KDK. We can still find the header in the XNO sources. So if we really want, we can create our Mac policy modules, although I bet Apple will not really like it. Although, again, they use it really extensively. So again, MFI, Sandbox, Endpoint Security, Gatekeeper is all based on this framework. So how it happens inside the source code, how this code out happens. So I took this snapshot mount system core because we will talk about it later anyway. So this is the system core stub, and there is a function called Mac mount check snapshot mount. So usually all these Mac functions starts with Mac underline and then the name of the hook. So if we go into this function, the Mac mount check snapshot mount, there are a couple of checks, and eventually it calls the Mac check macro, forwarding all the arguments along with the name of the hook it's interested. In this case, it's the mount check snapshot mount hook. So as I said, the Mac check is a macro. And what it does, it will basically iterate over all of the policy modules, check if the given policy module supports that given hook. And if yes, the hook will be called. It will call all of the hooks, like all of the policy modules, and aggregate the results. And the Mac check is actually the way it works. It will take the most restrictive decision. So if any of the policy modules denies the action, the overall action will be rejected, and the system call will fail, basically. So let's see how the mount system calls works. macOS uses the virtual file system switch framework or system. VFS has its origin from Solaris, and these days it's really used in most or possibly any Unix-based system like Linux, FreeBSD, Unix, whatever. Basically what VFS does, it makes a file system abstraction, so we can universally access any files folder and use the file system, and the VFS we use the actual driver responsible for the given file system. So regardless if we use APFS, HFS, or whatever, this is all transparent through the VFS. And because the interaction with the VFS happens through system calls, there are basically Mac policy callouts at possibly all points. So if you want to read a file, there will be a hook, a Mac hook, and it will be called. The sandbox will hook most of these system calls on VFS. So if we look at the mount system call flow, we actually have a couple of options to do a mount. There is a Mac mount system call, which eventually arrives to the mount common function, internal function, and the mount common function will call the Mac mount check mount Mac hook. Now, if we call the mount, the classic mount system call, what it will do is call into Mac mount right away. And again, it goes back to mount common. Mount common is the ultimate endpoint for all of the mount calls. So if we call f mount, that will go as well. Now there is the fs snapshot when we do operation with snapshots, which is a APFS feature. And if we want to mount a snapshot, then there is a snapshot mount call, and that function will call the Mac mount check snapshot mount Mac hook, which is specifically designed to check if the snapshot mounting is allowed or not, and then eventually ask to call the mount command function. We also need to talk about the disk arbitration service. So what is that? It's a system-wide service defined in one of the system-wide launch daemons. And it has an XPC service, the com-able disk arbitration D. We can reach it. And what it's used for, it basically manages disk mounting, unmounting, and a few other disk related items. And under the hood, it will actually call the mount and unmount system call, but it abstracts it away. So we can, if we don't want to call the mount system call ourselves, we can interact with the disk arbitration service itself, and it will do everything for us. Now, why we like it, why this service is interesting? First, it runs as root. It also runs on sandbox. The XPC services offers, it's accessible from the application sandbox. So we can see the application sandbox profile here, and we can see that the disk arbitration Mac service or XPC service is reachable. And actually it will be reachable from most of the sandbox application, like the system sandbox services. And it's also open source, so it's really easy to do code audit in it. Now, why it's important that it runs as root and on sandbox? So whenever it makes the mount system call, the mount system call will, as we discussed, do all these Mac policy hooks and check if the action is permitted for the given application or not. But what the mount system call will see is that it's being called from an application running as root, and an application is running as on sandbox. So basically, everything will be permitted unless we want to mount over some system integrity protection protected stuff. Otherwise, everything will go through from the mount system call point of view. Now, obviously, this can be abused if we call this service as a sandbox service with low privilege user. So the disk arbitration service have to do some checks to prevent abuse. So it will do a sandbox check call and check with the sandbox if the mount operation is permitted for that given application or not. It will also check if the location where we want to mount is owned by the same user as the process calling the disk arbitration service. And all of these checks happen in the DA server session queue request function inside the DA server C source code. Now, we will come back to this disk arbitration service later. So the first CV is from Patrick. It's the sniffing authorization references on macOS. He wrote a really detailed and really great blog post about the whole discovery and exploitation. So that could probably take a whole presentation just to go over that. So I will just cover the basics here. Some background for this CVE. Authorization, as is, can be passed between two processes on macOS through the authorization external form. And the security out trampoline function, it's an old function. It can execute privileged action. I believe this is also deprecated these days, but maybe not sure. And basically this function is using the authorization external form to pass authorization. So what happens when we call the authorization execute with privileges function, which will result on calling the security out trampoline function? It will write out the external form to the temporary directory into a random file, and it will also delete it. Now, if we can somehow get hold of this authorization reference, we can use it because it's global to the system, and it's actually just a random number. So if another application, like the security auth trampoline in this case, performs the authorization on this form, and if we can get hold of the form, we can use it and escalate our privileges. So what we can do is, that time it was possible to remove the temporary directory and create a new directory or a mount point in that location and mount a RAM disk in that location. And basically, whenever the authorization reference was written to our RAM disk, we could scan the raw RAM disk for this reference. And once it was authorized, we could actually escalate our privileges to root. So I think this was a really nice example of how to use the mount operation as an exploitation technique. And that actually inspired me to find other stuff. The next bug is from Pwn to Own. They called it the mount yourself a root shell. It was found by the FinHacks team, by Niklas Baumstark and Samuel Gross, and it was part of the Pwn to Own exploit chain in 2017. They also released a very good blog post about all the details. So again, I will just cover the basics here. So as I mentioned before, the disk arbitration service has to ensure that everything is fine in order to prevent abuse. So what happened is that this service checked if the mount point where we wanted to mount our disk existed, and then it resolved the paths of the mount point and checked if the user is the same as the user of the actual calling process. And later on, there were no any other checks. So if this check was passed, then everything is good. Now the problem was that they resolved the mount point location twice. So they resolved it here first, and then later on, when the actual mount operation was performed. So there is a time of check, time of use issue here. So it produced the race condition. So the way they exploited it, or it can be exploited, we create a symlink pointing to a user-owned directory. We call the disk arbitration service. The check will be passed. And then we repoint the symlink to a root-owned directory once the ownership check is passed. And if the mount is successful, we stop. And then, so the other issue is, okay, we can mount over a root-owned directory, but we also need to mount a disk image where the user has write access on the image. And for this, the EFI partition was perfect, because the regular admin user has write access or write access on this partition. Nowadays, we cannot mount it through disk arbitration because there is a specific check for the EFI partition UUID, and it will not pass. But we can also use other disk images. And here is a short demo of their exploit. And actually here I just use their original POC on, I believe, High Sierra. So we start the POC, it's a race condition, so it takes a while, not that long actually, just a couple of seconds. And the location where they mounted over the disk image, it was the cron tabs folder. And they created a new cron job as root, and that way they could escalate their privileges to root. Next one is from 2020, and it's a TCC bypass involving snapshot mounting, and this was found by myself. APFS has a feature called snapshots, and it's what it's called. We can make a snapshot of the file system and we can revert back to it later on. And this is a read-only snapshot. And what we could do, so TCC, the privacy frameworks, protects sensitive locations like desktop, documents, address book, and so on. What we could do is we could create a snapshot with the TMUTL utility that was allowed to be done by anyone, even the guest user. And we mounted the snapshot in a custom location. So in the example on the slide, it's the temp snap. Now the temp snap location as a mount point falls outside of the scope of TCC. So once we mounted the snapshot as read-only, we could access the entire file system in read-only mode, and we could access every file on the system. Now, on top of that, if we use the no owners flag on the mount operation, that meant that the snapshot was mounted with the no owners flag, which meant that we could access every user's file on the system and every user's private file. So in case, like in maybe large enterprises, multiple people using a MacBook or some Mac device, and maybe even if SSH is enabled, any user could access any other user's file locally. This was working even for the guest account. Now, the way Apple fixed this issue is first, under the hood, they introduced the Mac callout on the snapshot operation. So actually the Mac hook was introduced because of this bug on the snapshot operation. And they tied the snapshot mount operation to the full disk access right, which is a problem because this right is normally, so privacy TCC rights are given to applications and not users. So let's say one of the users uses terminal and gives terminal full disk access. And if the other user logs in, now he can start terminal and he can mount the snapshot and access the other user's file on the system. And this is still the case today. And Apple said it's fine. The next one from this year, it's the TCC bypass again, with involving the mount, some tricks. TCC, the privacy framework, all the access or most of the access is controlled through a database file. The TCC database file is found under the library application support com Apple TCC directory, and there is a tcc.db file. And there is also a system-wide tcc.db file on the root library application support and so on. So it's the same location. So one is in the user home folder and one is in the system-wide library. And of course, TCC protects this file, so we cannot edit the database, because that would mean we can add or remove rights and we could bypass TCC. But what we could do, make a disk image, create a new TCC database file, put in whatever you want in the database file, and take this disk image as a mount over the com Apple TCC directory, and restart the TCC daemon. And at that point, TCC daemon parsed the new TCC B file, which we mounted, because the original one is kind of hidden at that point. And basically, we could fully bypass the user mode DCC. And it was really funny. So again, here's a quick demo of this. So again, we don't have access to the documents folder. We run our exploit, which creates a new database, a new disk image, performs the mounting, restarts DCC, and voila, we can access the documents folders. And basically anything else you want, because we control the DCC database at that point. The next one is again a DCC bypass through the app translocation service. And honestly, this is probably one of my favorites. So the app translocation service, it was introduced as a security feature to address one of the vulnerabilities reported by Patrick. So you can blame him for this feature. And what it does technically, when we download an application and we don't move the application into the application's directory, where it normally would be, but run it directly from the downloaded folder, it will make a null FS mount. So it's not a copy, but it looks like a copy, but it's not. It's like an identity mount. So it maps the application into the temporary directory app translocation /d/d, and then the application name, and we run it from there. The app translocation service is open source as part of the security framework, and it's inside the lib security translocate library. Now, the binary that is responsible for the translocation is the USR libaccess LSD binary. If we check the entitlements of this binary, we can notice two things. One is that it has the KTCC service system policy all files TCC entitlement, which effectively means full disk access. And it also has a null FS allow entitlement, which allows it to perform a null FS mount on macOS. So the null FS mount on macOS is implemented, the feature is implemented, but you cannot do that unless you have this entitlement. And actually, this is the only binary on the entire system that has this entitlement, at least as of today. Okay, so what it does, it kind of copies or maps file to another location. And we arrived to the same idea what we had in the snapshot mounting. Because we want to map these privacy sensitive directories to another location. Now the translocate service will only translocate something if the quarantine attribute is on the directory. So what we do, we add the quarantine attribute to library, because why not? And then call the translocation XPC service and say that, hey, we want to translocate the library directory. And it will map it to the temdir app translocation DD library location as read-only, but that's fine. And we can then access everything through that path. And because the XPC client for the translocation service is also open source, it was super easy to create an exploit for this. Basically, we set the path and call the service, so it was quite straightforward. So here is the demo of this. We try to access the messages directory, which sorts our iMessages. Of course, it's not permitted because it's privacy protected. We call the translocate service on library. We can see the new path on the screen. And then if we use this new location, we can access messages. So this is another trick where we could use the mount operation, although not traditionally, for exploiting some service. So I bet Apple never thought about using app translocation for such items. So how did Apple fix these vulnerabilities? So first, in the past, we had to pass a pass location what we want to translocate. In the new translocation implementation, they actually expect a file descriptor. So we already need to have the ability to open that location. And they also introduced a couple of sandbox checks before the translocation even happens. So they will check a file read and the file mount, check if it's allowed or not. Now, this in itself doesn't change too much in terms of the library issue. So we can still open the library. We can still we can pass the file descriptor and so on. So it would still work. So we can still perform the translocation, but they also added a sandbox check when we access the new location. So basically, now even if we translocate the library folder, and now if we try to access files through that, it will not be allowed. And the last one is a privilege escalation, where I could again use a mount to achieve this. And I found this in the Fortinet 40 client installer. So what happened when the Fortinet 40 client was installed, or during the installation, it created several log files and put it inside the temp directory. This is unfortunately pretty common. The problem is that this is a predictable location, and because it's an installer, it's typically run as root. So all these files are being written as root. And because it's in a predictable location with a predictable file name, if we use a symlink or a hard link, we can at minimum perform an arbitrary override on the system, which is a denial of service scenario. So it's not that interesting usually. And the other issue with this log file is that it always had a fixed content. So no matter what happened, it was always the same. And there was no way I could impact what's being written. So, okay, we can do an arbitrary override. So I can overwrite a file on the system with this content. And I was wondering, okay, how can I turn this into code execution? And I overwrote one of the periodic scripts. So if I overwrite a periodic script, which are scheduled to run on either daily, weekly, or monthly basis, it will be interpreted as a shell script. If it's a shell script, basically, it will try to execute each line as if it was some command. Now, if we look through this list, basically what we need a binary somewhere that will be executed for us. And basically, the second line and the third line can satisfy it for us. But how? So I picked the third line, the volumes 40 client FCT data conf. And what we can do, we can create a disk image, call it 40 client. If we mount it, any low privilege user can do that. So if you call open DMG, it will be mounted over volumes and the name of the volume, in this case, 40 client. So I can create the volumes 40 client pass. And if I add the FCT data /conf inside my disk image, then I have a pass that is satisfied in this log file. And it will be run as root. So here's a demo of what happens. So we start with creating a symbolic link for this log file. we run the installer. It's done. And at this point, yeah, we eject the installer, but we could also do it from the command line. I just did it from the GUI. And if we check our periodic script, we can see that it was over with them with the log. We mount our own disk image. We check if the file we wanted is there. It is, which is the same that is inside the log file. And we can either wait 24 hours or call the sudo periodic daily to execute the daily scripts. And we have a pop-up as root. Because the binary actually launched terminal. So that's what it did. So for instance, I know installer packs are not always that cool, but I still see it sometimes as a nice exploitation trick or method to abuse installers. So how we can generically abuse these? So in case they write to a location which has a predictable name, like let's say temp, some fixed name directory, and maybe inside the directory they write out other files, maybe plist files, scripts, whatever. But the point is that at the temp under the temp directory, they always use the same name. So what we can do, we create a mount point in the temp fixed name and mount over a disk image with the no owners flag. So at that point, during the installation, we can modify any file the installer places in this location. And even if the installer tries to delete the temp fixed name directory, it cannot do that if there is a disk mounted on the mount point. So that operation will not be successful, and thus we even can overcome race condition scenarios where we would need to recreate this directory. And some new bugs that I cannot really cover because they are still under the fix, but I found these while working on this presentation. So it's always good to go back and check your work because I found another full TCC bypass. I found the sandbox escape and another TCC bypass. And I believe there is a fourth one now, but I can't recall exactly what. So thank you. That was all from me. Do you have any questions?
Awesome. That was amazing. I have a few questions. First, were your demos all live?
Sorry, I couldn't hear it very well.
Okay, let's try this again. Were your demos live that you did?
No, those were all pre-recorded.
Okay, because I was like, that was, I mean, still very impressive, but I always wonder. Also, could you briefly talk about your experiences with Apple Bug Bounty Program? Because I imagine you have submitted these to Apple, and I'd just be interested kind of on your take on your experience with that.
Generally speaking, not just these. Yes, I submitted these. It's bittersweet. So one is they do pay what's promised, so that's fair. But on the other side, that can take really, really long time. So for example, I still have vulnerabilities fixed with the initial release of Big Sur, and I think not all of them was reviewed for a reward. So that means I waited X months, maybe over a year, because that also happens that there are bugs I reported in Catalina and they will be fixed in Monterey. So you wait, let's say, maybe a year or even more, then the vulnerability is fixed, and then you wait another year just to be decided that you get a reward or not. But eventually, when they decide that, hey, you do get a reward, they pay out usually in a month. So that part is fast. So yeah, the other issue is the lack of communication. So it's sometimes you feel that you send your emails or follow up into a spam folder or a black hole or something. I'm pretty sure they read it, but often there is no response. I also realized that there are only a handful of people replying to open cases. So I think there are like 5 or 6 people responding. So they might be overloaded with all the bugs or submissions. So they maybe cannot just reply so frequently. But come on, Apple has a ton of money. They should hire them more people to handle the cases and actually communicate better with the researchers. So, but actually, so the product security team is still better than the other teams at Apple in terms of communication. So it's also not perfect, but at least they are better than like the developer relations. So that's that's something. At least.
Yeah, no, thanks for sharing your insights in that. That's good. I know you had some experience. Sounds like there's some pros and cons, but it seems like patience is the key. Are there any other questions for Csaba? All right, Csaba, hold on. I'm going to turn around the laptop so you can see everyone. Let's give Csaba a round of applause.